Just imagine an endless plain. Then there's a slope, encompassed by the waves of an ever-restless sea. Add to this the extreme pressure and winds of tremendous force. The sky is completely obscured by a dense canvas of clouds. Only in the distance, on the horizon, does a red sun peek out. Just a moment later, the sun disappears behind the clouds. It's barely visible now. Yet the sun doesn't actually change its position. But that hasn't stopped it from being hidden from our view. Look around you. This seems to be the last place any living organism could exist. Yet things aren't as straightforward as they seem. We've just described what the so-called second Earth might look like. On this planet, researchers might also search for extraterrestrial life. So, what is this intriguing planet like? As you may know, in recent decades, scientists have discovered a vast number of exoplanets. The count stands at 4,370. These celestial bodies are located in approximately 3,230 planetary systems. Around 3,000 of these planets are in the process of being confirmed as exoplanets. Typically, such objects are enormous. Gas giants, super-Earths, and super-Jupiters are among them. Technically, exoplanets, large bodies that orbit their stars in a short period, are easier to detect than smaller ones. Exoplanets can surprise us not only with their size, some might even harbor life. Dozens are considered candidates. They are a gold mine for researchers. Among these planets is Gliese 832c, located in the Crane constellation. Scientists believe that this exoplanet has the highest probability of harboring life. The primary star it orbits is named Gliese 832. The distance between it and our Sun is 16 light-years. The star is a dim, red object. Gliese 832's luminosity is a mere 0.7% of the Sun's. Its mass and diameter are about half that of the Sun. The temperature of Gliese 832 is approximately 3,026 degrees Celsius. Consequently, its habitable zone is quite narrow. Due to tidal forces, objects in this zone experience tidal locking. This means they always face one side towards their star. The most famous example of tidal locking is the relationship between the Moon and Earth. It's confirmed that two planets exist in Gliese 832's habitable zone. One of them, Gliese 832b, discovered in 2008, shares characteristics with Jupiter. This planet's mass is 2/3 that of Jupiter. And it's about 3.4 astronomical units from its star. In 2015, a second planet was discovered, Gliese 832c, with an Earth similarity index of 0.81, considered high. Such a discovery couldn't escape the attention of the global scientific community, and naturally the media. As a result, Gliese 832c earned another name, the second Earth. However, these two planets are quite distinct. Still, the fact remains, this exoplanet has a notably high Earth similarity index. The exoplanet's mass is equivalent to 5.5 Earth masses. Gliese 832c orbits its host star every 35 Earth days. The distance between the star and the exoplanet is 0.6 astronomical units. For reference, the distance from Earth to the Sun is 1 astronomical unit. A unique feature of Gliese 832c is its orbit, which occasionally takes it out of the habitable zone. This might cause rapid temperature fluctuations. Interestingly, the energy Gliese 832c receives from its star is roughly equivalent to the solar energy Earth receives. On average, the planet's temperature reaches -20 degrees Celsius. It's believed that Gliese 832c has a dense atmosphere, which could elevate temperature readings. We've already noted the high likelihood of the planet being tidally locked to its star. Additionally, its habitable zone is narrow, indicating that the distance between Gliese 832 and Gliese 832c is minimal. Since planets are always turned to one side of their host star, there are stark temperature differences between the illuminated region and the dark one. If the atmosphere's density is high enough, hurricanes might occur on Gliese 832c. In the Gliese 832 system, there might not just be 2 exoplanets, but possibly 3. This was the conclusion reached by scientists from the University of Texas in 2017. The hypothetical planet's size is estimated to be between 10 to 15 Earth masses. It is between 0.25 and 2 astronomical units away from its host star. The existence of a third planet has yet to be confirmed. More data is needed for verification. However, let's refocus on Gliese 832c. Imagine what this exoplanet might look like if it harbored life. The gravity on Gliese 832c would likely be much stronger than on Earth. We're uncertain about the planet's exact diameter, so we can't provide a precise gravity measurement. However, we do know that the density of Gliese 832c is comparable to Earth's. Thus, the exoplanet's gravity might be around 3 times that of Earth. Such conditions could lead to a more uniform topography. Ocean depths might be shallower, and mountains might not be as tall or steep. This could be seen as favorable for life, as there would be more regions with potentially warm water. In terms of Gliese 832c's appearance, its landscapes might predominantly be red due to the dim light and dense atmosphere. Since the exoplanet is tidally locked, the dark side would be cold, while the illuminated side would be warmer. In the transitional region, where the lit side meets the dark, temperatures would be most conducive for life. This is also where the most precipitation, likely in the form of liquid water, would occur. Near the boundary with the dark side, glaciers might melt, increasing the water volume. However, a significant challenge would be the incredibly strong winds caused by temperature differences. These winds might be mitigated by tall mountain ranges, but given the planet's gravity, such heights might be unattainable. The exoplanet orbits in an elongated path, but it's relatively close to its host star. As a result, seasons might change weekly. When the exoplanet is nearest its star, it experiences summer. At its farthest, winter. The planet's axial tilt might not have a significant impact. Instead, the distance between Gliese 832c and its star would be the primary factor. On such a ring-shaped exoplanet, the changing seasons might produce effects similar to Earth's tidal forces. There would be high and low tides. Some regions might periodically flood, only for the waters to later recede. During these processes, various particles could mix in the water, potentially creating ideal conditions for life. Scientists theorize that life on Gliese 832c might be exclusively aquatic. The rationale is that in the oceans, the effects of gravity and temperature fluctuations are significantly reduced. Potential life forms could adapt to the frequent seasonal changes, either migrating to more hospitable areas or entering a state of dormancy. In such states, extreme conditions wouldn't pose a threat. Let's envision what these beings might look like on Gliese 832c, or perhaps what they already resemble. Plants might resemble moss and would likely be dark to absorb as much sunlight as possible. These plants would need to withstand powerful winds, so they'd have robust root systems. Given the atmosphere's density, some organisms might evolve to exist within the atmosphere rather than on the surface. These beings could move with the wind, extracting essential nutrients from the air. Of course, all these ideas are speculative. What are your thoughts on what we might discover about Gliese 832c?